All right, we want to look at right triangles. Now, the first thing that we're going to look at here is in a right triangle, we know from middle school mathematics that the hypotenuse is always across from the right angle, and it's also always going to be the longest leg. Now, I've listed this one guy called opposite side and this other leg called the adjacent side because each of the two legs are going to be one or the other, but it all depends on where the angle is. Now, I put the angle right here. Now, it looks like 0, but that is actually the symbol here, theta. It's just an unknown. We usually use this Greek letter to stand for missing angles. Instead of an A or an X or a Y, we use theta, okay? Theta. Now, so there's theta. Notice that the guy across from him is going to be called the opposite side, and the side it's sitting on, which is right beside it, is called the adjacent side. So you're going to have the two legs that form the 90 degrees are going to be opposite and adjacent. And then you have the hypotenuse. Now, let's look. So let's look at this right triangle. We have theta right here. Now, where's the hypotenuse? The hypotenuse is across from the right angle. So the hypotenuse has got to be there. If theta is located up here, who's this over here? This is going to be my opposite side. And then right beside me is going to be my adjacent side. In the next picture, well, here's your right angle. So here's your hypotenuse. Here's theta. So across from theta, that's going to be my opposite. And then right here beside me that I'm using and resting between your adjacent side and your hypotenuse. Notice right here, theta is between the adjacent and the hypotenuse. But it's easy, the opposite's easy to find. It's just across from it. It's the side across from the angle. You have to have that down pat first. Now, if we look at an example, let's say we have a 30-degree angle. Well, the relationship, believe it or not, with a 30-degree angle, the side across from it, the opposite side, for every 1 inch it is, your hypotenuse will be 2 inches. And that's always going to be true because as you enlarge the shape or shrink it, it's going to stay at that same ratio. So if this opposite side is 3 inches, what do you think the hypotenuse would be? Well, we just said the ratio is going to stay the same, so it's going to be 6 inches. Excuse me. Now, we're going to look, because that was one special relationship, a ratio between the opposite side and the hypotenuse when it was 30 degrees. But let's say we have all these sides. We need to look at how many different ratios exist. Well, we just saw the opposite and hypotenuse relationship. We just did that. What else could exist? Well, you could have the adjacent side related to the hypotenuse. Is there anybody else? Well, I'd see one more. You could have a relationship between this opposite and your adjacent. I see 3 relationships that could exist, different ratios. Well, they do exist, and somebody has recorded what every single one of them be. For when this is 1 degree, the relationship between opposite and hypotenuse. When it's 1 degree, the relationship of what it will be, the fraction will be between the adjacent and the hypotenuse. And then they also, the relationship between the opposite and the adjacent. And they've recorded every one of these, so we can look them up and see what they are. Which means if we're given one, we can find the other because we know what it's got to come out to equal. So we needed names for these 3 different relationships. Well, here are the names. We gave the first one the sine, and the sine is the relationship between the opposite side divided by the hypotenuse, which is what we did to begin with, where if that's 30 degrees, for every 1 inch, this is going to be 2 inches. And it might be that when it goes to 29 degrees, it's 1 inch, and this is for 1.96 or something. But anyway, sine is going to be your opposite over hypotenuse. Cosine will be your adjacent over your hypotenuse. And finally, tangent, which is abbreviated tan, will be the relationship between the opposite side and the adjacent side. So we came up with names for the 3 different ratios. Well, how are we going to remember that? Here's how we remember it. We remember it with this expression. Now, again, we do not promote drugs at all, but just a little catchy phrase. Some old hippie caught another hippie tripping on acid. So some old hippie, which is sine being opposite over hypotenuse, called another hippie cosine, which is adjacent over hypotenuse, tripping on acid, which tangent opposite over the adjacent. It's just a little mnemonic device to help you remember it. You should have seen that before. It's nothing new. Now, let's look at how we're going to solve these. Here's the way I like to approach this. First, item 1, the angle is right here. So we must identify the sides we're dealing with. We have the hypotenuse and we have the adjacent. So I say to myself, some old hippie caught another hippie tripping on acid. Which one of these has the H and the A in it? H and the A is right here. So we're going to use the cosine. Now the cosine says the cosine of the angle, which is 40 degrees. Now I'm always going to put it over 1. That's a little different than most. Equals, it says adjacent on top. Now don't put adjacent on the bottom. It's the adjacent first, the top, which is unknown X, over the hypotenuse, which we know to be 8. Now, with these, we will cross multiply. Let's move down a little bit. Cross multiply. X times 1, well, that's X. That's our unknown side, is equal to 8 times the cosine of 40 degrees. We're going to need a calculator for this. If we go back and we look, I got a calculator here. Notice that right here, this button, it says radian degree. You want to make sure that it's in degree mode. And what I wanted to type, we wanted to do 8 times the cosine of 40. So I do 8 times cosine 40, and it equals 6.12. So that will be our answer. So we'll go back here and we'll say, hey, X is approximately 6.12. Another example, we look at this. Here's my angle. I have opposite and hypotenuse, because that's across from the right angle, the 10 is. So I say to myself, some old hippie caught another hippie tripping on acid, which has O and H in it. O and H, that's this one. So we're going to say the sine of the angle, the sine of 25 over 1 equals the opposite X over the hypotenuse 10. And now we cross multiply. X times 1 is X. It's going to equal 10 times the sine of 25 degrees. We could go to our calculator, type that in, make sure you're in degree mode. We're going to get 4.23 approximately. What about this one? Okay, well, here's my angle. I got opposite, and I got this adjacent, right? So I have opposite and I have adjacent. Some old hippie caught another hippie tripping on acid. Looks like you got opposite and adjacent, so you're using the tangent relationship. So the tangent of 20 degrees over 1 equals the opposite. Who is opposite? That was 6 over your adjacent X. This is why I always sort of write them as fractions here, because look what happens. It's not as pretty as last time. We end up with these multiplied. X times the tangent of 20 degrees, whatever that is, that's just some number. Someone has already recorded what that has to be, equals 6 times 1, which is 6. Now, if I want to get X by itself, I'm just going to divide by whatever that tangent of 20 degrees is. Whatever I do to the one side of the equal sign, I must do to the other. And then I'm simply going to type in 6 divided by the tangent of 20. And I got 16.48 when I did it earlier. All you got to make sure you do is you set them up correctly. And then you simply cross multiply and you'll have your answer. Just make sure your calculator is in degree mode.